country is renowned for its quality vegetables, succulent fruit, and we all want to continue this tradition. Consumers demand an immaculate product. They don't want worm-eaten apples, half-eaten leeks, or caterpillars in their lettuce. However, they're also against the use of chemicals in food production. Producers want to give consumers what they want, but they must also consider the demands of a viable business. Weeds choke the plants. Diseases and pests reduce the profitability of agriculture and horticulture and decrease the competitiveness of our products in both domestic and foreign markets. Healthy products require a healthy environment. To this end, more and more methods are being used to protect the environment against diseases and pests. These include cultivation techniques and biological and mechanical pest control. But this is not always enough or appropriate for all crop types, which is where chemical control comes in. In-depth research into better plant health products has been carried out in recent years.
Pesticides of the latest generation are more selective, more efficient and more environmentally friendly. Through careful calculation, we can determine exactly the right dosage. Such economical consumption allows us to minimize the burden on both environment and farm budget.
Furthermore, new spraying equipment ensures that the carefully prepared and diluted product ends up precisely where it's needed and in the right quantity. All these efforts are in vain, however, if the spraying equipment itself is faulty or has been incorrectly adjusted. The government shares the concern of producers and consumers alike, and is also concerned to ensure that plant protection methods are used safely, economically, and efficiently. Using an insufficient amount of pesticide fails to kill off the parasite properly. In the long term, it can even contribute to the build-up of resistances. On the other hand, too high an amount of applied pesticide gives rise to an increased, intolerable concentration of residue, which may remain too long on the plants. The plant withers or the fruit becomes inedible. If weed killer is applied in the wrong place, it can easily destroy nearby plants. Either way, there's a loss. Expensive protective agents and costly time are wasted at the expense of both the plants and the environment. It's therefore vitally important that the spraying equipment should be perfectly maintained at all times, in excellent operational condition and completely reliable. For this reason, the government, in a ministerial decree of the 9th of June 1995, has introduced compulsory regular inspections of all spraying equipment used within Belgian territory. The Ministry of Agriculture appoints the institutions authorized to carry out the inspections. The Research Station of Agricultural Engineering in Merelbeke is the authorized body for the inspection for the whole of Flanders.
The inspection services must report to a steering group at least twice a year. This steering group consists of representatives of the various agricultural organisations as well as civil servants from the Ministry of Agriculture. The steering group has the authority to adjust the testing procedures each year.
Lever-operated knapsack sprayers and portable compression sprayers, however, are excluded from this compulsory test. The test applies to all other spraying equipment used in agriculture and horticulture, including fruit growing and greenhouse growing, in recreational areas and on sports fields, and in the maintenance of roads, railway embankments, and so on. The inspection takes place approximately once every 3 years. All spraying equipment must have been subjected to its first inspection before the 31st of December 1998. At the time of purchase, registration is obligatory within 30 days. This is the responsibility of the seller if the customer is the user, or the responsibility of the customer if he imports the equipment directly. When the user decommissions a spraying appliance, he must also report this to the inspectorate within 30 days.
Compulsory testing has existed for some time in countries such as the Netherlands and Germany. In other countries such as Sweden, Denmark and Austria, they take place on a voluntary basis. Even here, various farmers and horticulturists have been using the services of our inspection department for environmental and economic reasons, or of their own accord. The research station of agricultural engineering has suitable testing equipment and expert staff. A timetable will be produced and all owners will be called for inspection of their spraying equipment well in advance.
No later than 15 days in advance, the owner will be requested by letter to present his appliance for testing. The following 3 items of information can be found on the invitation: date, time, place and instructions. The spraying appliance must be well cleaned and therefore contain no traces of pesticides. The tank must be 3/4 filled with pure water. The inspection is always arranged locally. The user will not have to travel more than 10 kilometers. At the inspection site, the cost of inspection is first paid. This contribution is set in accordance with the working width of the equipment which is presented for inspection. Up to 12 meters, the basic price of 2,500 Belgian francs applies. For equipment with a greater effective width, the basic price is increased by 150 francs per extra meter. A maximum fee of 4,000 Belgian francs is charged for 22 meters or more.
This contribution is insignificant in comparison with the real cost of plant protection. Even according to the most generous calculation, these contributions barely amount to a few tenths of 1% of the total farm budget for pest control. In practice, it has been found that malfunctioning equipment can disperse up to 80% too little or up to 400% too much product. This test therefore prevents unnecessary costs.
When the farmer arrives, his details are compared with those from the census, and the details of the spraying equipment are filled in. First of all, we look at the general condition of the appliance, the protection of the power takeoff and the readability of the sight gauge. If the spraying equipment has a balancing mechanism for the spray boom, we check the balancing system. We test the hinges and ends of the spray boom for sturdiness. Next, we look at the intervals and direction of the spray nozzle holders. The filter housings are checked to determine the presence and cleanliness of the filter parts, the feeder basket, the pressure filter and the suction filter. A plugged or dirty pressure filter causes considerable loss of pressure and irregular distribution. The suction filter is also taken out of the filter housing, visually assessed and then replaced. The first stage of the test involves an administrative part and general visual checks. This is carried out for all types of spraying equipment. In this case, it's recommended to tie the cables more securely and to protect the power takeoff with a non-rotating cover. Here also, all filters should be in place so as to prevent blockages. The spraying equipment should preferably be fitted with a sufficiently large pressure gauge so that the pressure can easily be read. Every single filter is inspected. Now we move on to field spraying. After the visual checks, we proceed to the working of the spraying equipment. In the past, spraying tables were used with voluntary testing in Flanders. We set a constant height. And then switch the equipment on. The sprayed liquid is channeled into vessels through ducts 10 centimeters wide. If enough fluid is collected, the beakers are carefully tilted away beneath the ducts. The content of the beakers reveals the quality of the spray and, more in particular, spray distribution. It's impossible at this stage to determine the cause of any improper operation. The present testing method is no longer based on the spraying table, but on pressure readings from the spray nozzles. To do this, a nozzle in each section is replaced by a pressure gauge, spray nozzle combination. The pressure must be equal and stable in each section. In this case, unequal distribution is caused by unstable pressure. Possible causes for pressure fluctuations are either a defective air chamber or pressure in the chamber being too high or too low. If the air chamber is in order, then a mixture of liquid and air is sucked into the pump or the supply pipe. The procedure for orchard sprayers is slightly different. Here we don't measure the pressure, but the spray output of all nozzles on the appliance. Therefore, special adapters with accompanying pipes are installed on the nozzle holders. When spraying is started up, the liquid is collected in beakers. Here, once again, we observe differences between the amounts of liquid collected in the various vessels. Irregular spraying with this equipment can be corrected simply by replacing the worn spray nozzles with new nozzles and rubber seals. The new nozzles must, of course, also be checked. New spray nozzles give a more uniform distribution. Regular cleaning of the nozzles extends their lifetime. After all these tests, the user receives a report with comments and remarks. It also provides details of faults to be remedied. These points are then discussed with the farmer and indicated on the appliance. All other types of testing equipment which have been the subject of numerous discussions, such as the vertical spraying table, are as yet not used in the compulsory tests. Nevertheless, this wall will still be used for the voluntary tests of different types of orchard sprayers and for adjusting them where necessary. In the case of computer-controlled spraying equipment where the flow rate is governed by the speed of travel, we compare the actual output with the chosen flow rate. First, a 100-meter course is marked out. Once this is done, we attach a number of small calibrated plastic bags to the spray nozzle holders. The liquid which is sprayed during the 100-meter course is collected in the bags. After a run-up of a few meters to reach a constant speed, the sprayer is switched on at the first marker. At the same time, we also measure the speed. Spraying stops at the second marker. The content of the calibrated bags is read off and recorded. Using these figures, we calculate the total delivered volume per hectare and this result is compared with the preset spray volume. The nozzles are now removed for individual testing. The required equipment to test the spray nozzles is permanently installed in the van. Using the test equipment, we compare the output rate of each separate nozzle with that of a new nozzle. To do this, we place all the nozzles in the appropriate notches on the board. We verify whether all nozzles are of the same type and have the same characteristics. The details of each nozzle are automatically recorded on the computer, which rules out any errors. The equipment is also fitted with high-precision measuring instruments. The limit for rejection for a whole series of nozzles is an average deviation of 5% for the whole series and 10% per individual nozzle. For the last test, we remove the pressure gauge from the sprayer. The working pressure gauge is compared with a calibrated instrument in the appropriate pressure range. Once all the tests have been completed, a report is issued with the necessary comments. And if no faults were found, a green numbered sticker is placed on the sprayer. The sticker states the period of time during which the equipment is allowed to be used before re-inspection. The objective and serious testing of spraying equipment, as stipulated in the ministerial decree, will no doubt contribute towards a healthy crop and farm management and enhance consumer confidence in produce from our own soil.